Gradient descent is an algorithm that is very commonly used in machine learning. We will now get the intuitive idea behind gradient descent and how it works. So imagine you're out walking on mountains and you need to reach the bottom of a valley where your house is, and you're going to be somewhere in that valley, but we don't know exactly where in the valley. And the issue is that it's very foggy and we can't really see far from where we are standing. We can only see the terrain where we are standing, so we can only tell which way is downhill and which way is uphill. So the idea is that I will ask you, by just giving you information about which way is downhill, left or right, so by just giving you information about the slope of the terrain where you're standing, you should be able to tell me whether you want to move left or whether you want to move right, considering that you want to reach the bottom of the valley where the house is. So in this scenario, you will hopefully say that you want to go right, to go downhill, and then we walk for a while, and then we check the terrain again, and then I ask you again, do you want to go left or right? And then hopefully you will say that you want to continue going right. And then if this is what I showed you, you will say that now you want to move left. And with this, you will reach your home. So the idea behind the gradient descent algorithm is exactly the same. The idea now is that we have some parameters, beta, and we want to modify the values of our parameters by going downhill. Downhill the error rate, or downhill the loss function. So we want to minimize the loss, we want to minimize the error, we want to minimize the cost, different names referring to the same thing depending on the algorithm that we're working on. But the idea is that we want to minimize a value. So we want to go downhill of the curve that value represents. So how do we do this mathematically? Because yes, intuitively, we just saw how to do this, but then if we define what is the loss function that we want to minimize, you may be thinking, okay, but I don't want the actual value of the loss. I want the slope now. I want to know what is the slope of the terrain next to me, meaning what is the slope of the loss function next to where the value of the parameter lies now. And the answer to that is we use the derivative of the loss function. As you can see in the curve on the slide there, the derivative gives us the slope of the line that is tangential to the curve at each given point. And with that, we know which way is downhill. As I said here, beta will be the parameter to which the error function depends. So the error depends on the data and the targets X and Y, but it also depends on beta, which are the parameters that define our decision or our classification algorithm. Okay, so once we know the slope for our parameters, we can now apply that slope to our parameters and update them. And usually this slope is multiplied by a constant or by a value that is called the learning rate. And as you can imagine, the larger this learning rate is, the bigger the step, the larger the step we will take in the direction of downhill, and then the smaller this learning rate is, the smaller the step. We don't want to take too large a step, because then we may overshoot the bottom of the valley, we may overshoot the minimum of the loss, And we also may end up in a unstable situation where we overshoot, and then we try to go back and correct, and we overshoot again, and then we keep oscillating around the minimum. So we want to find a good balance between a large value so that we reach the bottom quickly, and a small value so that we don't overshoot that bottom point.